So now we're going to start working through some problems with ellipses, and this will mainly involve graphing ellipses, and you're going to see this is pretty straightforward. I think everybody's going to like it. It's not nearly as complicated as it might seem at first. The previous video involved the derivation of the equation for an ellipse, and you can watch that if you want. You don't have to. The handout that I'm projecting right now, the typewritten handout on ellipses, includes everything you need to know about ellipses as well as the problems we're going to work through together. So the handwritten handout with all those details, you can take it or leave it. That's not required. So here, let's get down to working out some problems. So what do we need to know? We're only going to look at ellipses that are centered at 0, 0 with major and minor axes on the coordinate axes. So the picture might look like this or like this. In fact, I hate to even give you two different versions because really we're going to see that we don't even have to distinguish between the two. The only reason there's two forms of the equation here is because most textbooks like to call A the length of half the major axis. So if A is on the x-axis, we want that A squared in a certain position. If A is on the y-axis, we want this A squared in a different position. But don't worry if you don't distinguish between these two forms of the equation, x squared over A squared plus y squared over B squared equals 1, and the other one, because that's not really going to be necessary for us to see that difference. What we are going to use in some of these exercises, though, is this formula a squared minus b squared equals c squared, which helps us find the foci. That's only going to be used for focus parts of the problem. And so let's get started on a graph. So what you do have to do, though, is you are going to have to recognize when you see an equation like x squared over 9 plus y squared over 4 equals 1, it's going to have to seem like an ellipse to you so you know which procedure to start working on. And I think, again, I don't think this is going to be a problem in the rest of the course. Usually people pick up the look of an ellipse equation pretty quickly. On the handout, I also outlined the steps to drawing the graph, so it's all written out here in words, what we're about to go through together on this sheet. So let's start exercise 1, which I recopied here onto this graph grid. Graph x squared over 9 plus y squared over 4 equals 1. So you want to recognize that this has the look of x squared over a squared plus y squared over b squared equals 1. So it has that look of the general form of the equation of an ellipse. So you should feel like, yep, I think this is an ellipse that I'm about to start graphing. Our process for graphing an ellipse is always going to start out with finding the intercepts. And really the intercepts are going to be our basis for drawing the graph. So let's look for x-intercepts. We're going to set y equal to 0. I'm going to take my equation x squared over 9 plus, I'm going to plug in 0 for y, so I'll have 0 squared over 4 equals 1. So I have x squared over 9 plus, that's just 0 equals 1. 0 squared over 4 is 0. So now I have just x squared over 9 equals 1. And I'm going to multiply both sides by 9. To cancel the 9 on the left, I get x squared equals 9. And I have a little quadratic equation where I have to take square roots. X is going to be plus or minus square root of 9. X is plus or minus 3. So we do get two square roots here. We have to get both the positive and the negative. We have two x-intercepts, 3, 0, and negative 3, 0. Now let's look at the y-intercepts. That's when x is equal to 0. So we take our same equation. I'm going to set x equal to 0. So 0 squared over 9 plus y squared over 4 equals 1. And once you go through this a couple times, you're going to see that this standard form is really kind of set up to make it not be too difficult to find the intercepts. So 0 squared over 9 is 0, plus y squared over 4 equals 1. And so I just have y squared over 4 equals 1. I'm going to multiply both sides by 4 to cancel the 4 there. Y squared is 4. So y is plus or minus the square root of 4. Y is plus or minus 2. I got two y-intercepts because of the two square roots. So 0, 2, 0, negative 2 are the two y-intercepts for my ellipse. And really, once we find the x-intercepts and the y-intercepts, we pretty much can draw a graph at this point. So let's go ahead and do it. And let's see. I'm going to just try to spread out a little bit here. Let's see. 2, 4, 6, 2, 4. Okay, and down. So I'm hoping I can set this up. I was going to go 2 squares with each unit. Let's go 1, 2, 3, 4 on the x-axis, 1, 2, 3 on the y. So -1, -2, -3. Whoops, going off the edge. There's -4. Okay, so let's plot these intercepts now. I got 3, 0, -3, 0 on the x-axis. I got 0, 2, 0, -2 on the y. And I just got to draw an ellipse that will pass through those points. So I'm just drawing an oval curve. And that's essentially the graph that we're trying to obtain. Now I ask you to label, so 0, 2, 0, -2, 3, 0, -3, 0 are my intercepts. Now, I don't mind if you don't write the word vertices, co-vertices. Technically, the vertices are at the end of the longer of the two axes, so the vertices are 3, 0, -3, 0. The co-vertices are on the minor axis, so 0, 2, 0, -2. But you can just label the coordinates, that's fine. And but now we need to find the foci. And to do that, we got to make use of that a squared minus b squared equals c squared equation. And you don't really have to even be conscious of whether whether we had where the a and the b was in our original equation, because a will always be larger than b, a squared will always be larger than b squared. So when I look at my intercept values, I know 3 is the a, so a squared is 3 squared. I know 2 is the b, so I have -2 squared, because 3 is bigger than 2. It's really just sometimes a is on the y-axis if I have a bigger intercept value on the y-axis. But here I don't. Here are the bigger values on the x. So 3 squared minus 2 squared is 9 minus 4 equals c squared. This 9 and this 4, they're the same as the original 9 and 4 in the denominators of the equation. We could have just plucked them out of the denominator of the original equation. I give 5 as c squared. Once again, I got to take square roots, plus or minus. The square root of 5 is c. And here my square root doesn't simplify. And what I do have to be aware of now is whether my foci are on the x-axis or the y. The foci are always on the major axis, the longer one. So I know they have to be on the x-axis here. So I know these are x-coordinates, and the y-coordinates of the foci are 0. And it helps me a little bit to get my calculator out here. 5, square root of 5 is about 2.2. So this is about 2.20 and negative 2.20. And let's go ahead and plot those. So at about 2.2, about negative 2.2, and I'm just going to label this as negative square root of 5, 0. And this guy is positive square root of 5, 0. And if you want, you can put it like a f and an f prime, just to let everybody know that you know those are the two foci. So there's our graph for the equation x squared over 9 plus y squared over 4 equals 1. And again, just plot the intercepts, draw the ellipse. It's a little bit more work finding the foci we'll always use that a squared minus b squared equals c squared to find the foci. All right, let's do one more. There we go. This is the second exercise on that handout. So it's very similar. We're just gonna, we just have a slightly different look to the equation. Notice that we don't have our 1 on the right-hand side. We want a 1 here for standard form. So what I could do is I could take this equation. To get a 1 there, I could divide by 25. So I could take my equation and divide both sides by 25. And I have 25x squared over 25 plus y squared over 25 equals 1. 25 over 25. I can also cancel the 25s here, so I have x squared plus y squared over 25 equals 1. Okay. Now, if you're saying, well, wait a minute, aren't we supposed to have one fraction plus another fraction equals 1 in those standard forms, right, that we've seen here and here? Well, this x squared that occurs all by itself, we can just think of that as x squared over 1 plus y squared over 25 equals 1. So that is in our standard form. So let's go ahead and find the intercepts. And let's see, x-intercept, set y equal to 0. And if I set y equal to 0 in this equation, I have, it doesn't matter whether I use this form, or the original form for that matter. X squared plus 0 squared over 25 equals 1. So x squared plus 0 equals 1. X squared is 1. X is going to be plus or minus the square root of 1. So x is plus or minus 1. I get 1, 0. Negative 1, 0 are my x-intercepts. Let's do y-intercepts. So set x equal to 0. I'm going to have 0 squared plus y squared over 25 equals 1. So of course that x term drops out. I have just y squared over 25 equals 1. Here I have to multiply both sides by 25. I get y squared is 25. Y is plus or minus the square root of 25. So y is plus or minus 5. 0, 5, 0, negative 5 are my y-intercepts. And I think that's enough for me to be able to draw a graph now, right? Once we get both the x and y intercepts, we can sketch a graph. And I'm going to put it over here on this portion of my graph grid. I think I have room here. And so x-axis, y-axis. Now this is sort of a funny looking one because my x-intercepts are just at 1, 0, and negative 1, 0, right? My y-intercepts are 5 units up and 5 units down. So I have this really elongated ellipse here. Elongated in a vertical sort of way. And notice I didn't have to know ahead of time which value was A, which was B. I just plot my intercepts. I got 0, 5. I have 1, 0. I have 0, negative 5. And I have negative 1, 0. Technically, 0, 5 and 0, negative 5, our textbook would call the vertices because they're on the major axis. Negative 1, 0, 1, 0 are the co-vertices because they're on the minor axis. And but again, you don't even have to be conscious of vertex, co-vertex to draw that graph. But now let's find the foci. We're almost done. So we're going to use our a squared minus b squared equals c squared equation. And I need to know which is A and which is B. The larger of these two intercepts is going to be the A value. The smaller is going to be the B. So 5 is larger. I take 5 squared minus 1 squared is c squared. 25 minus 1 is c squared. 24 is c squared. So plus or minus the square root of 24 is c. That's plus or minus. Now, if you deal with square root of 24, that's fine, but it's nice if you can recognize that we can factor out a perfect square of 4 from 24. So I get plus or minus 2 radical 6, right, equals c when I take that square root of 4. And now to plot it, I would need a calculator value here. I can either take the square root of 24 or work with the 2 square root of 6. 4.9 is about my c value. So square root of 24 is about 4.9. So I'm going to be, I'm going to be right up against, I'm kind of not putting it all the way where it should be just because I won't be able to see that dot. If I do, and I'm going to use arrows to label these coordinates. So this is 0, 2 radical 6. This is 0 minus 2 radical 6. And I'll label that F and F prime, the two foci for my ellipse. And so there we are. We just graphed our number 2 equation. And I'm going to stop this video here. We're going to continue more examples in our next video.